Hi, I'm Srija. I'm from CSDC section department. Today I'm here to speak about maximal correlation regression on the topic. So I prepared some slides about maximal correlation regression information. So firstly we come to introduction. Maximal correlation regression is also called as MCR. In the shortcut form we use MCR for maximal correlation regression is a statistical technique used to identify the relationship between two sets of variables. It is used when there is a need to understand the relationship between two sets of variables that have a high degree of correlation. Maximal correlation regression is a useful tool in fields such as finance, economics, and marketing. On the right side of this slide, we have some seven graphs which are about scatter plots and correlation examples. First graph is R is equals to 1. When R is equals to 1, it is perfect positive correlation. And when R is equals to zero point 0.8, it is highly positive correlation. And when it is R is equals to zero point 0.3, it is low positive correlation. And when r is equals to 0, it is a horizontal line, straight line. It has no correlation. And coming to another three graphs, these graphs about negative, which means r is equals to minus 0.3. It has low negative correlation, and r is equals to minus 0.8, which is highly negative correlation, and r is equals to minus 1, it is perfect negative correlation. So upper ones are about positive correlation and down one graphs are about negative correlation. Now we discuss about correlation and regression. Firstly, we discuss about their definitions of correlation. The correlation definition is the relation between the two variables such that a change in variable results in positive or negative change in the other, and also greater change in one variable results in a corresponding change in the other is called a correlation. Correlation measures the strength and direction of the relationship between two variables. And some methods of correlation are Carl Pearson's correlation coefficient and Spearman's rank correlation coefficients. In Carl Pearson's correlation coefficient, the definition is this method is also called as product moment correlation coefficient. This is denoted by small r, and Spearman correlation coefficient is this method is based on rank and is useful in dealing with qualitative characteristics such as molarity, character, intelligence, and beauty. It is based on ranks given to the observations. Rank correlation is applicable only to the individual's observations. Therefore, rank correlation coefficient is P is equals to 1 minus 6 sigma d square by n into n square minus 1, where d square denotes sum of squares of difference of two ranks, and n is number of observations. And some properties of Spearman's rank correlation coefficient is the value of p lies between plus 1 and minus 1. If P is 1, there is complete agreement in order of the ranks and the direction of the rank is same. If P is equals to minus 1, there is complete disagreement in order of the ranks and the direction of rank is opposite direction. And these are some properties of Spearman's rank correlation coefficient, and properties of Carl Pearson's correlation coefficient are correlation coefficient always in between minus 1 and plus 1. If R is equals to 1, the correlation is said to be perfect and positive. If R is equals to minus 1, the correlation is said to be perfect and negative. If R greater than 0, the correlation is positive. If R less than 0, the correlation is negative. If R is equals to 0, the correlation is 0. These are some properties of Carl Pearson's correlation coefficient. And here, regression estimates the relationship between a dependent variable and one or more the independent variables. Maximal correlation regression combines the principles of correlation and regression to identify the relationship between two sets of variables. And some more information about regression is the statistical method which helps us to estimate the unknown value of one variable from the known value of the related variable is called regression. We have regression line also. It is nothing but the line describing the average relationship mm, mm, between two variables is known as regression line, and it is also called as estimating line. A regression line is a straight line fitted to the data by the method of least squares. It indicates the best possible mean value of one variable corresponding to the mean value of the other. So here regressions are also of two types, like regression lines are of two types. First one is regression line y on x, and the second one is regression line x on y. And here in this slide we have about how maximal correlation regression works. Maximal correlation regression involves finding the linear combination of variables in both sets that has the highest correlation coefficient. The linear combination is then used to create a new set of variables which can be used to predict the other set of variables. Maximal correlation regression can be performed using various techniques including principal component analysis and partial least squares regression. And on the right side, we have correlation coefficients like three graphs. First one is positive correlation, and second one is negative correlation, and third one is it's a horizontal straight line. It is no correlation. So now we discuss about the benefits of maximal correlation regression. Maximal correlation regression is useful when there is a high degree of correlation between two sets of variables, making it difficult to identify the relationship using traditional regression techniques. It provides a simple and efficient way to identify the relationship between two sets of variables. Maximal correlation regression can be used to identify hidden relationships in large data sets. So on the right side, we have some logo of logo type scientific and educational maximal correlation regression. And we have some limitations of maximal correlation regression is maximal correlation regression assumes a linear relationship between the two sets of variables. It may not be suitable for data sets with a low degree of correlation between the two sets of variables. Maximal correlation regression requires a large sample size to produce meaningful results. Assumptions of Carl Pearson's coefficient of correlation, as we discussed earlier. Uh, Linear relationship exists between the variables. Properties of Carl Pearson's coefficient of correlation is value lies between +1 and -1. 0 means no correlation, and the gamma is equals to under root bxy into byx, where bxy and into byx are regression coefficient merit. Convenient for accurate interpretation as it gives degree and direction of relationship between two variables. And now we have some applications of maximal correlation regression. Maximal correlation regression is commonly used in finance to identify the relationship between economic variables such as interest rates and stock prices. It is used in marketing to identify the relationship between customer behavior and demographic variables. Maximal correlation regression can also be used in the field of genetics to identify the relationship between genetic markers and disease. So not only in the mathematics we use maximal correlation regression, but also outside the mathematics, like in the medicine, the field of science, also we use maximal correlation regression to solve some genetic markers and some genetic diseases. We use maximal correlation regression. Now we have some example of maximal correlation regression is a study was conducted to identify the relationship between economic variables and stock prices. Maximal correlation regression was used. Maximal correlation regression was used to identify the linear combination of variables that had the highest correlation coefficient relationship between economic variables and stock prices. The results showed that interest rates, inflation, and GDP were the most important variables in predicting stock price. So these are some examples of maximal correlation regression. And we have a bar graph here. It is about linear, parabolic, cubic, exponential, linear or periodic, sinusoidal Fourier frequency, sinusoidal Fourier non-frequency, sinusoidal varying frequency, and random. We have nine bar graphs. And in vertically, we have some values like from 0, 0.01, 0.02, 0.03, and up to so on 0.09. From this bar graph, we can understand that both the straight lines are about optimize x-axis and the cross lines are about all. So some criticisms of maximal correlation regression is maximal correlation regression has been criticized for being too simplistic in its approach to identifying the relationship between two sets of variables. Some argue that it is not suitable for data sets with complex relationships. Others argue that maximal correlation regression is limited in its ability to identify causal relationships. On the right side, we have some pictograph like pictograph means picture like now maximal correlation regression has passed to be just another fictional character in my mind. As in my head, Gerard will always be revenge Gerard. It's a so these are some criticisms of maximal correlation regression. And we also discuss about the future of maximal correlation regression is maximal correlation regression is likely to continue to be an important tool in fields such as finance, economics, and marketing. As datasets become larger and more complex, there will be a need for more advanced techniques to identify relationships between variables. Maximal correlation regression may be combined with other techniques to improve its accuracy and effectiveness. And if the two variables deviate in the same direction, the correlation is said to be direct or positive. If the variables deviate in the opposite direction, the correlation is said to be inverse or negative. If the change in one variable corresponds to proportional change in the other variable, then the correlation is said to be perfect. And we come to the conclusion about maximal correlation regression. Maximal correlation regression is a useful statistical technique for identifying the relationship between two sets of variables. It combines the principles of correlation and regression to create a new set of variables that can be used to predict the other set of variables. While it has some limitations, maximal correlation regression is a valuable tool in fields such as finance, economics, and marketing. As correlation is a relationship between two variables. The data can be represented by ordered pairs like x comma y, where x is the independent or explanatory variable and y is the dependent or response variable. Now we see a scatter plot can be used to determine whether a linear correlation exists between two variables. I mean whether a linear or straight line correlation exists between two variables. So we have taken some values like x and y. In x we have 1, 2, 3, 4, 5, and y in y we have -4, -2, -1, 0, 2. As the given values, we drawn a graph. The graph was like this. So this is about the conclusion, and I took the references through I prepared my slides. The references which I took the slides from is Abdi. It is in the year from the year 2007, and Chatterjee, which is designed by in the year 1991, and Gold H in the year 1966. These are some references from which I have taken my slides. So I hope you understand about maximal correlation regression through my slides. Thank you.